Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 6 on Elements and the Periodic Table, and we're going to be covering 6.1, the Periodic Table today. So, you are made of stardust. What? Yeah, it is true. The Big Bang produced hydrogen and helium and a tiny bit of lithium, which spread out throughout the universe, the known universe, and then um, over time coalesced into stars, and then those stars began nuclear reactions, and then during the nuclear reactions the lighter elements formed into heavier elements, and then when that star got to the end of its lifetime, it would explode out, and then so the heavier elements exploded into stardust, and then they would coalesce eventually into a new star, and so on and so forth, until the star, like the star that exploded that formed our solar system and our sun, came to be. And yeah, so all of the particles on Earth, and so therefore all the particles that make up you, came from a previously exploded star. I think that's fun. You, what elements make up you? Well, we're a lot water, so hydrogen and oxygen, and this is percent by mole, make up a large percent. Carbon, nitrogen, we also have calcium, phosphorus, potassium, sulfur, sodium, chlorine, magnesium, iron, a little bit of iodine. And we have these that we noted in green, and then also some trace elements like fluorine, iodine, nickel, copper, zinc, stuff like that. Right, so please write this down. The most common elements in the human body are hydrogen, oxygen, carbon, and nitrogen. Macronutrients are elements needed in large quantities in your body, and they are all of these, plus sodium, Na, magnesium, Mg, phosphorus, P, sulfur, S, chlorine, Cl, potassium, K, and calcium, Ca. So please write those down. And then other elements are present in small quantities, and they are considered trace elements. In Chapter 5, we learned about the structure of the atom and what we knew when and how we knew it. So in Chapter 6, we're going to learn about elements and the periodic table. So we're looking at 1869 with Dmitri Mendeleev, and he comes up with the modern periodic table. And so this is, long time after Democritus came up with the term atom, about 100-ish years after Dalton's atomic theory, and before we knew anything about the structure of the atom, like the nucleus, protons, neutrons, and electrons. Periodic table organizes all of the elements. And please write this down. There are 118 elements. The elements are categorized into metals, nonmetals, metalloids. So I want you to think about, where are the metals found, where are the nonmetals found, where are the metalloids found, and I want you to think about, what are the properties of metals, what are the properties of nonmetals, and what are the properties of metalloids. If you recall from a previous chapter, an ionic compound is when one nonmetal atom bonds with a metal atom. For example, sodium metal bonds with chlorine nonmetal, or we could have potassium bromide, potassium the metal, bonds with bromine the nonmetal. And also there are covalent compounds. Your book also calls them molecular compounds, and that's when two nonmetals bond with each other. For example, carbon dioxide is a covalent or molecular compound. Nitrogen monoxide is as well, and there are so many others. So a question I have for you is, what does the periodic in periodic table mean? So let's look at some properties that are periodic, or that they repeat every so often. So Mendeleev organized the periodic table and saw properties of elements were periodic. The atomic radius is the distance from the center of an atom to its outer edge. So the atomic radius is a property that is periodic. It repeats every so often. And what is it? It is just like what a radius is. It's the distance from the middle to the edge of a circle. So what he found, and what you can find, is that the atomic radius will decrease as you go from left to right in a row on the periodic table. So please write all that down. Why does it do that? Well, it does that because there are more protons. Every time you go right one element, you gain another proton. And more protons means you can hold those electrons closer, and so the radius gets smaller. The atomic radius also increases as you go down a column. It gets bigger. And why is that? Well, that is because there are more electron shells. So the edge of the circle is getting further and further out. So on the first row you have 1 electron shell, in the second row you have 2 electron shells, in the third row you have 3 electron shells, and it's just getting bigger and bigger. So Mendeleev, back in the late 1800s, could not have measured atomic radii, but he could measure density of certain elements. And he organized them in order of increasing mass, and he found out that there was a pattern. As you see with the density, it goes up until we get to a certain point, and then it starts over again, and then it goes up, and then it starts over again. You can see it starts over again in like group 1 elements: hydrogen, lithium, sodium, potassium, rubidium, and cesium. And so it's getting bigger as you go from left to right, and then it starts over again. So he noticed that the properties of elements were periodic, and that was a really important thing to notice. And we can nowadays measure atomic radius, and just like density, the atomic radius has a repeating pattern. You can see that it gets smaller as you go from left to right, and then when you go to the next row it jumps up again, and then it gets smaller as you go from left to right, and then it jumps up again, and then it gets smaller as you go from left to right. And let's take that picture and put it in perspective. We're going to cut out the transition metals because we can, and it'll make things easier. So we see as you go from left to right, the atomic radius gets smaller, and then it jumps back up again as you go to the group 1, and then it gets smaller. And then when you go to then row 3, it jumps up again, and then it gets smaller as you go from left to right. So again, as you get more and more protons, they're holding those electrons closer, and then as you go, so it gets smaller, and then as you go down, you add another shell of electrons, so that radius is getting bigger. Looking at one more graphic of atomic radius, you can see as we go from left to right, it goes from bigger to less shaded smaller, and then it gets bigger again when we get to group 1, and then it gets smaller, and so forth. And then as we go down, it gets bigger. All right, so let's look at another property. Let's look at electronegativity. Electronegativity is the measure of an atom's ability to attract another atom's electron. Basically, how electron greedy, electronegativity, is an atom. So the electronegativity increases as you go from left to right in a row. Why does it do this? Well, metals, which are on the left side, do not want any more electrons. They want to get rid of the ones they have. So they are not going to be good at attracting another electron. But as you go right, you get your nonmetals, and they want more electrons. So you're going to go from low electronegativity, a low ability, to a high ability. As you go from left to right, it's going to get bigger. What about when we go from down a column? The electronegativity is going to decrease. Why is that? Well, the protons aren't as good at drawing in electrons because they're further away as you get more and more shells. So as you go down a column, you get more and more electron shells, so those protons are further and further away from the outside electrons, so they are not very good at pulling in somebody else's electrons. So as you go down a column, those elements get less. They're not as good at pulling out other people's electrons, so their electronegativity decreases. Okay, let's look at a picture of this. We can see as we go from left to right, our electronegativity increases. It gets darker here. And then as you go from go down, it actually gets lighter. So the most electronegative is up here, and then it decreases as we go down the column. You can see that most of the noble gases don't form ions, so they're not colored purple. The third and final property we're going to talk about is ionization energy, the energy needed to make an ion. So ionization energy is the energy needed to remove an electron from an atom. So to remove an electron is to make it charged. A charged particle is to make it an ion. So if you ever forget what it is, just look back at the name, ionization energy, energy needed to make an ion, which means you remove an electron. So the ionization energy increases as you go from left to right in a row. And why is this? All right, so metals on the left want to give away their electrons. So they're willing to just give them away. So it's going to take you very little energy. You don't have to pay much money at all. So very little energy to take away the electrons on the left side of the periodic table. On the right side, those nonmetals do not want to give away their electrons. You have to put in a lot of energy because they really do not want to give away those electrons. So the amount of energy is going to go up from left to right in a row. What about going in one column? As you go down a column, the ionization energy decreases. And this is because protons aren't as good at holding their electrons because they're farther away from the outer electrons. So if you, the ionization energy needed to take away an electron is going to be low because those protons are really far away from their outside electrons. So it doesn't take much energy to get rid of them. So the ionization energy, as we can see, goes as we go from left to right. It takes more energy to remove an electron. And then as you go down, it takes less energy to remove an electron. Before we dive into how Dmitry Mendeleev came up with this ingenious tool called the periodic table, let's do a review of the 3 periodic properties that I want you to know. There is ionization energy, the energy required to remove an electron from an atom, which will increase as you go from left to right and decrease as you go down a column. There is also the electronegativity, which is the ability of an atom to gain another atom's electrons, and that is also going to increase as you go from left to right and decrease as you go down a column. And then there is the atomic radius, which is the distance from the center of an atom to its outside edge, and that is going to decrease as you go from left to right and increase as you go down a column. All right, we are going to have, in our next video, we're going to talk about how the periodic table came to be. All right, I'll see you then.